Explain the flyweight design pattern. The flyweight design pattern is a structural pattern used to minimize memory usage by sharing objects instead of creating them repeatedly. This pattern is extremely useful when you have a large number of objects that are similar and differ only in a few attributes. Instead of creating a new object for every request, the flyweight pattern creates a small pool of reusable objects and returns shared copies whenever possible. In simple words, flyweight reduces memory consumption by reusing existing objects and avoiding unnecessary duplication. This pattern becomes powerful when dealing with scenarios like rendering millions of characters in a text editor, displaying thousands of trees in a game, catching icons, catching database objects, or minimizing object creation in high-performance systems. Now let's understand this pattern with a practical and very easy demonstration. We will create a shape system that draws circles with a specific color. If many circles share the same color, we should not create new objects every time. Instead, we reuse the existing circle from a flyweight factory. Here is the complete working code. We begin by creating a shape interface with a method named draw that accepts x and y coordinates for drawing the shape. Next, we create a class called circle that implements shape. Circle has one intrinsic property, the color. The color is intrinsic because it does not change from one circle instance to another if the color is the same. In the constructor of circle, we print a message saying creating circle of color, so we can observe when new objects are created. Inside the draw method, we print the color and the position to simulate drawing the circle. Now comes the core component of the flyweight pattern, the shape factory. Shape factory uses a hash map to store created circle objects by color. The method getCircle checks whether a circle with the requested color already exists in the map. If it exists, we simply return that object and do not create a new one. If it does not exist, we create a new circle, store it in the map, and then return it. This ensures we never create duplicate circle objects for the same color. Now let's walk through the main method to see this in action. Inside main, we call shapefactory dot getCircle with the color red. Since this is the first request, the factory creates a new red circle and stores it in the map. Then we call draw on this circle and pass coordinates 10 and 20. Next, we request another red circle. This time, the factory sees that a red circle already exists in the map, so it does not create a new one. It returns the existing object. We call draw again, and the circle is drawn at a different position but using the same shared object. Now we request a blue circle. Because blue has not been created before, the factory creates a new blue circle and stores it. Next, we request another red circle. Again, the factory returns the same shared red circle and no new object is created. This demonstration clearly shows that flyweight avoids duplicate objects by reusing existing ones based on intrinsic values. If we run this program, you will notice that creating circle of color red prints only once, even though red is used 3 times. This confirms that the flyweight pattern saves memory by sharing objects. Now let's see. When should you use the flyweight pattern? Use the flyweight pattern when your application creates a large number of similar objects that share the same intrinsic state. Use it when memory usage is high and you want to reduce it by reusing objects. Use it when object creation is frequent and you need to improve performance. Examples include text rendering, game engines, drawing applications, object caching, and repeated UI components. Here is the short interview answer to explain this pattern. The flyweight design pattern is a structural pattern used to reduce memory usage by sharing objects instead of creating them repeatedly. It separates intrinsic state that can be shared from extrinsic state that must be supplied from the outside. A flyweight factory stores shared objects and returns them when needed instead of creating new ones. This pattern is ideal for systems containing many repeated objects, such as text editors, game engines, UI toolkits, and caching mechanisms. That is the complete explanation of the flyweight design pattern.